So I want to go ahead and get started on our whole multiple choice section of exam 1. So let's go ahead and begin. I think I've done these quite a few times, so these might be a little bit quicker than most of the solutions you're used to, but we've done these a lot, and I'm kind of hoping that these are making a little bit more sense. So we want to know what happens if we, which graph is distance versus time for positive acceleration. If you actually look at the choices here, I hope it's clear that this is choice D. These are all, this is not moving. This is positive constant velocity. This is negative constant velocity. This is actually going backwards and speeding up. And speeding up. So you've got all these choices here. Now, ball is thrown up straight up from a point 2 meters above the ground. So let me just draw the ground here. Now we're 2 meters up. We throw the ball straight up. Reaches maximum height of 3 meters. And then it falls 5 meters back to the ground here. What is this displacement from the starting point? 2 meters below. And that's it. Now, so 2 meters below. Now, next problem. We have a 500 kilogram sports car reaching 30 meters per second in 6 seconds, and we want to know how far it goes in 6 seconds. So first, let's get the acceleration. That's 30 divided by 6 is 5. And then distance equals 1/2 AT squared, so that's going to be 1/2 times 5 times 36. That's 5 times 18. So hope I did that right. 36 times 5 divided by 2 should be 90 meters. There's something fishy about that. I just want to make sure I got that right. So the acceleration is 30 by 6, which is 5. 1/2 AT squared, so that's 1/2 times 5 times, yeah, I guess it did. Cool. Now, problem number 4. Man, Newton's third law, equal. Just whenever, if it's a bug in a truck, a tree in a thing, I don't care. There's actually, I should just have us do the demo for this, but like, yeah, whenever you get one object exerting a force on another, I don't care what they look like, they're always equal and opposite, and we'll actually do a little demo for that later on. Now here we've got 2 objects connected by a light pulley. I love how they just kind of add this mass here, but this is just plain old 0.9 kilograms, and this is 0.6 kilograms, so we've got a tension here and a tension here. So when we actually use gravity as 10, we're going to have 9 minus t equals 0.9a, and we have t minus 6 equals 0.6a. So let's combine these equations. So we're going to get 15, no, 9 minus 6 is, let me just double check this. So 9 minus t equals 0.9a, t minus 6 equals 0.6a. So when I combine these, I'm going to get 9 minus 6 is 3 equals 1.5a. And I'm actually going to need an acceleration of 2 meters per second squared. Do they want the acceleration or the tension? Looks like they want the acceleration. Good deal for us. So here, we've got a 5 kilogram mass. And it looks like we're pulling this thing up at a constant speed with the force F. Is there friction? There is friction. So we've got our work cut out for us, so let's just get a free body diagram on here. We're going to have a normal force. I'm in a hurry to do these problems in multiple choice, so I'm not going to be as careful with my labeling. So I'm going to have mg here. This will be, mg straight down, so we'll have mg sine theta here, and mg cos theta here. And we're going to have friction here. So let's be clear on how this works. We're going to have mu mg cos theta plus mg sine theta balances that applied force going upward. So let's plug in some numbers. So I have 0.3 times 50 times cosine of theta. So horizontal's 4, vertical's 3, and the hypotenuse is 5. So cosine theta is going to be 4/5, and mg sine theta, that's going to be 50 times 3 over 5. So this gives us 30 here. And then what do we get here? 4. So 4. This is 10 here when we cancel the 10, 50 and the 5. So that's going to be 12 plus 30, and that gives me 42 newtons of force here. In the absence of friction, what happens when we have this acceleration of 9.8 meters per second squared? The speed of this is not true. No. 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 This would be true if this were velocity. So the only one left is A, which is in fact the right choice. Now question 8. Let's see, parabolic path. Oh boy, this problem comes up in so many ways. Look, when you fire something with no air resistance, I don't care what it's doing or what it looks like, the acceleration is always straight down, and the force is always straight down. Okay, that's how it is. Okay, every other effect is inertia stuff, so don't even worry about it. It's just straight down. So you barely need to read that here. We fire a gun at an angle of 45. So H if it's fired straight up. What's the height if it's fired at 45 degrees? So let's be clear here. So V naught squared over 2G equals H normal, right? Now, how does this compare to the new height if we fire at 45 degrees? Well, if we fire at 45 degrees, sine theta is 45. And our new height is going to be V naught sine theta quantity squared over 2G. And that's going to be V naught squared times sine of theta squared, which is 1/2 when we square radical 2 over 2G. So it seems to me that we're going to be actually going up H over 2 in our height. Good stuff. Now here, we want to know the net force when we get this position here. So force net is mass times acceleration, which is going to be m times x double dot. So the derivative is going to be 3t squared minus 6t plus 9. Second derivative is going to be 6t minus 6. Did I get that right? No, this is minus 12t. Minus 12 here. So this is x dot. This is x double dot. Just out of curiosity, let me just solve for t when the acceleration is 0. 6t minus 12, that gives me t equals 2. And oh, notice they want to know when the net force is 0, and that happens at t equals 2. So good stuff. All right, let me just see how I am on time. Good. Boy, what's going on here? So we got some kind of block, and man, let me just draw a free body diagram here. So we're going to have normal, and we're going to have weight, and this seems to be friction, and then we have some kind of force F here. So here, this is going to be F cos theta, and we got this F sine theta here. So let's figure out what's going on. Let's get the acceleration of the block. So they give us F, so F cosine of phi minus friction equals ma. So that's choice D. Now what's the coefficient of friction? Let's figure that one out. So we know that friction is mu n, and that's going to be F over n for mu. So that's going to be F over, let's see, I'm just going to do an absolute value because my brain's not working, mg minus the normal, the normal force is going to be the weight minus F sine theta. So F sine phi, or whatever that angle is. So I'm getting choice E. Excellent. Now, next one. An object's released from rest. We got some air resistance. So it'd be a good idea to start memorizing this formula here, since you've solved for it a zillion times. Here's another one. You push on a block, and let me just move this over, just in case. Push on a block with force F. We got friction. We got weight. So let's solve from the end. We got normal going this way. So what we're saying is that friction equals mg, and the minimum friction is mu n equals mg, so n equals mg over mu to make this thing balance. So that's choice C. because then the normal equals the force, and we just got that that's n. Awesome. 16. So this is speed versus time. So what's acceleration versus time? If this is a parabola, it's a straight line. So that means the force is going to be this guy here, E. All right. Next question. Whoa, what's the value of tension in the slanted chord? Look at that. So T sine theta equals 100 to balance. And so that gives us T times a half equals 100. So that's going to be 200 newtons for T. Notice they also give half the answer, so that's another good one. So here. Velocity component of a projectile launches a projectile component VH and a vertical component VH, VY, whatever. Air resistance is negligible. We want to know some things about it at the highest point of its trajectory. At the highest point of its trajectory, let's be clear, none of these choices is right. Acceleration is always G. Horizontal velocity doesn't die out, and that leaves us choice E. 19. Here, so descending elevator. Let's see. We got descending elevator. We got a tension of the cable. We get the weight of the elevator. So we got T minus mg equals ma. And let's try to figure this out. So we have an 11,000 Newton tension minus 1,000 times 10 equals m, which is 1,000 times A. So I'm getting A is 1 meters per second squared. Now, what are they asking me? The speed of the elevator at the beginning of the descent and the slowdown over 8 meters. So let's see. 0 squared, my final speed, equals v at the beginning squared, minus 2 times 1 times 8 meters. So I'm getting v squared equals 16, so v is going to be 4 meters per second. Now, a ball is tossed straight up from the surface of the moon, rises to a height h, and then falls straight towards the surface of the moon. Let's see, what's true here? Only a gravitational force that acts downward exists. So which forces act? I should have corrected that. So that's it for the multiple choice part. Sorry to sound so glib, but we've done these about a zillion times, and I hope you guys are kind of taking notes, figuring these out, and getting them done. So good luck.